Alright, so in this problem, I have 100 to the power of x is equal to 200. So to solve this, I'm going to first take the log on both sides. So now I have log of 100 to the power of x is equal to log 200. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 100 to the power of x, and I can move x to the front. So now I have x times log 100 is equal to log 200. Now I'm going to divide both sides by log 100. So then these two cancel out, and now I have x is equal to log 200 over log 100. Now log 200, this is the same thing as log of 100 times 2. And I have this over log 100. So now if I have something in the form log of a times b, this is equal to log a plus log b. So log 100 times 2, that's going to equal log 100 plus log 2. And now I have this over log 100. So now I have log 100 over log 100 plus log 2 over log 100. Now log 100 is simply equal to 2. So I have 2 over 2 plus log 2 over log 100. Which is equal to 1 plus log 2 over 2. Alright, so in this problem, I have 4 to the power of x plus 10 to the power of x is equal to 25 to the power of x. So I'm going to first start by dividing all my terms here with 4. 4 to the power of x. So now 4 to the power of 4 to the power of x cancel out, so I have 1 plus 10 over 4 to the power of x is equal to 25 over 4 to the power of x. Now 10 over 4, that's the same thing as 5 over 2. And 25 over 4, that's the same thing as 5 over 2 squared to the power of x. And 5 over 2 squared, that's the same thing as 5 squared over 2 squared to the power of x. So now I'm going to let u equal 5 over 2. So now I have 1 plus u is equal to u squared. So now if I rearrange this, I get u squared minus u minus 1 is equal to 0. So I'm going to use the quadratic formula to solve this. I'm not going to waste your guys' time, but you should get, if you do end up using the quadratic formula, u is equal to 1 plus or minus the square root of 5 over 2. So now remember how we said u is equal to 5 over 2 to the power of x. So this means that 5 over 2 to the power of x is equal to 1 plus or minus the square root of 5 over 2. So this gives me two equations. 5 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 5 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front, so now I have b times log a. So in this case, I have log 5 over 2 to the power of x, and I can move x to the front. So now I have x times log 5 over 2 is equal to log 1 plus the square root of 5 over 2. Now we obviously want to isolate x, so I'm going to divide both sides by log 5 over 2. So then these two cancel out, and now I have x is equal to log of 1 plus the square root of 5 over 2 over log 5 over 2. Now, 1 minus the square root of 5 over 2, this wouldn't work because 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it a negative number. So this is wrong, and this is my only solution. Alright, so in this problem, I have 2 to the power of m minus 2 to the power of n is equal to 2016. So at first glance of this problem, I know that 2 to the power of m is greater than 2 to the power of n. Because if 2 to the power of m was less than 2 to the power of n, then this would not be a positive number, this would be a negative number. So if 2 to the power of m is greater than 2 to the power of n, then this also means that m is greater than n, because they're both the same base. So now that I know that m is greater than n, this must mean that m is equal to n plus some number k. So k is just a constant, some number. So now I'm going to replace m with n plus k. So now I have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k, that's going to equal 2 to the power of n times 2 to the power of k. Now this minus 2 to the power of n is equal to 2016. Now I'm going to factor out 2 to the power of n. So now I have 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So 2016, this is equal to 32 times 63. So as you can see here, 2 to the power of n, this is going to be an even number, right? Even, because 2 to the power of any number is even. Now 2 to the power of k, that's even, but an even number minus 1 is going to be odd. So 2 to the power of n is even, and 2 to the power of k minus 1 is odd. So now 32 here, this is even, and 63, this is odd. And notice how both of these are in the form a number times another number is equal to another number times another number. These two numbers are even, these two numbers are odd, meaning 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So these are my two equations. First off, 2 to the power of n equals 32. We know that n is equal to 5 because 2 to the power of 5 is equal to 32. And 2 to the power of k minus 1 equals 63. I'm going to first start by adding 1 on both sides. So now I have 2 to the power of k is equal to 64. So 2 to the power of what number equals 64? 6, meaning k equals 6. So I have my value for n and k, so all we have left to do is find the value of m. And remember, m is equal to n plus k. So n is 5, k is 6, meaning m is 11.